Okay, starting chapter 9 in grade 8, and chapter 9 in grade 8 is called linear relation. And as we study linear relations, we're going to realize that really there's two skills you really need to have when you study chapter 9. And the first skill is you need to know about the Cartesian plane. And of course, the Cartesian plane back in grade 7 was an x-axis and a y-axis. And you had all your points here, which were your 1, 2, 3, your negative 1, 2, 3, 4. On your y-axis, you had 1, 2, 3, 4, and your negative 1, 2, 3, 4. And every point that you had in here had what was called a coordinate. So this point here was 2 on the x and 1 on the y, so it was a 2, 1. This one here was a negative 1 on the x and a negative 2 on the y, so its coordinate was negative 1, negative 2. And we called these ordered pairs, okay? So that's the first thing you need to know. You need to understand your Cartesian plane and your x-axis, y-axis, and you need to understand what ordered pairs are. The second thing you needed to know is your algebra sense. Algebra. So you need to know that in the equation 2x plus 1 equals, let's say, y, 2 is called your coefficient, and your plus 1 is called your constant. And your x, y values are called variables. Okay, so that's a basic overview of the skills you need to have for chapter 9. So let's just start with a little graph here. Okay, and we're going to keep it simple. We're going to call this 1, 2, 3, and 4. This is your x-axis, and then we're going to make this. We'll make this 4, 8, 12, 16, and 20. So notice when we draw a graph, notice the space between here and here is 4 units, and every other line that we have is also units of 4. That's important when you create a graph, that you make sure that the axes, or the x and your y axes, have equal spaces between them. They don't have to be identical. So here we have each space represents 1 space. Here we have every space represents 4. That's okay. Just make sure that when you're here, you don't have this make 1, and then you have here, you have something like 6, and then 7, and then 12. You can't do that. You have to make sure that the spacing is equal. So here we're just going to basically define it as being 1, 2, 3, and 4. So the first thing we're going to do is we're going to put in some points, and I'm just going to put in 3 points. I'm going to put a point right here, and I'm going to put a point right here, and I'm going to put a point right here. Now, I know that's not a perfect line. I know they're not exactly perfect. But if we were to define these 3 points, we would say that the points are 1 on the x, 8 on the y, 2 on the x, and 12 on the y, and 3 on the x, and 16 on the y. So when we put our ordered pairs, we always put our first x-axis location, so in this case 3 first, and we put our y location second, 16. And if we look at those 3 points, you probably realize that those 3 points, if we were to connect the dots, make a line. Okay? They make a line. And the line stops here, and the line stops here. So it actually makes a line segment if we connect the dots. And what you can do with those 3 points is you can create a table of values with them to show the relationship between x and y. So the first point that we have here, 1, 8, if I was to bring it up here and put it into that space, my x value is 1, my y value is 8. So I've taken my ordered pair and I've put it into a table of values. This is called a table of values. My second pair is 2 on the x and 12 on the y. And my final one right here is 3 on the x and 16 on the y. Okay? So those are 3 pairs that we have on our line. Now, if I was to extend this line forever, and extend this line forever, I would still create points, and on those lines, there would be infinite numbers of red dots that we could put. And each one of those red dots has a relationship to each other. And what that's called is it's called a linear relationship. Okay? So how do we define the relationship between x and y? Well, back in grade 7, what you learned to do was you learned to look for the relationship between an x value and a y value, and you learned to create equations with it. So one thing we could say is this first relationship of this pair could be taking the x value and adding 7 to it gives you the y value, right? Because the x value here is 1, and if I add 7 to it, I get the y value, which is 8. That's one way to do it. I could also say about that one that if I take my x value and multiply it by 8, in this case 1, and multiply it by 8, or a coefficient of 8, I would get my y value as well. And there's other ones we could do. We could say you could also take your x value and multiply it by 2. So in this case, x is 1, so multiply it by 2, I get 2, and add 6, and I get my y value. Okay? And there are infinite equations I can create from that 1, 1, 8 value. Now from this other pair, 2, 12, I could say I could take my x value and add 10 to it, and I get my y value. That's one. That works. I could take my x value and multiply it by 6, or a coefficient of 6, and that gets my y value. And there are a whole bunch of other ones we can do as well for that. However, there is one equation between the values of this pair of 1 and 8, this pair of 2 and 12, and this pair of 3 and 16 that is the same for all three pairs. And I'm going to tell you that that relationship is multiplying the x value by 4. So in this case, 1 times 4 is 4. Adding a constant of 4, and that will give me my y value. So if we look at that first pair of 1 and 8, okay? And if I was to substitute 1 for the x and 8 for the y, because my x value is 1, my y value is 8, then I would see this is 4 plus 4, and 4 plus 4 equals 8. So both sides work out to be true. That if x is 1, then y is 8. And if I take that same equation and look at the second pair, if I say 4 multiplied by the new x value of 2 plus 4 will equal the new y value of 12, is this true? Yes, it is. Because 4 plus 8 is 12, and 12 equals 12. And we'll find that it works for the last one as well. If I take my x value of 3 and add 4 to it, I will get the y value of 16, because 12 plus 4 is 16. So this equation of 4x plus 4 equals y is the equation that matches every point on this line, even the points that are in between. So just to show you real quick, if I was to take this point right here and this point right here, so if I was to put a point on that line, here our x value would be 1.5 and our y value would be 10. So if I was to put a point right here on that line, even though I didn't have one before, and if I was to take this equation, 4x plus 4 equals y, and I was to substitute 1.5 for my x and 10 for my y, 4 times 1.5 is 6, and 6 plus 4 is 10. So this point here actually still does fall into the equation. That point, when the x value is 1.5 and the y value is 10, this equation, 4 times the x value plus y equals, or plus 4 equals y, is true. So we can say that all points, this point here, and this point here, or better yet, these three ordered pairs, and every ordered pair in between, doesn't matter where, all fall into the equation 4 multiplied by the x value plus 4 will equal the y value. Now, the trick is, how do I do this systematically? How do I figure out what my equation is? Because I just told you what the equation was. But how can I figure it out every time without having to do what we learned in grade 7, which was trial and error? Well, there's an easy secret, and I'll explain it to you. What we have to realize is that the coefficient of x, I spelled this wrong, that's okay, I-C-I-E-N-T. The coefficient of x, which is your, if I was to put the relationship between x and y, the coefficient of x, which is your number that would be multiplying the x value, there is a formula we can use to figure out what that is. And the coefficient of x is equal to the difference of the y column divided by the difference of the x column. What does that mean? Well, if I look at my table of values here and I look for the difference in the y column, and this is the y column here. So if I was to go down here and figure out what is the difference between those numbers, and difference, of course, means subtraction, so 12 take away. The difference between 8 and 12 is 4. And of course, this difference, if it's linear, should be consistent with every number in this column. So every one of them, you're going up by 4 in every pair. The difference of x, however, if I look at the difference in the x column going down here, is going up by 1 each time. So if I take my formula, the difference of x, so the difference in the x column we already said was a positive 4 going up by 4. The difference in the x column, excuse me, I think I said the other one before. The difference in the x column was going up by 1. So if I substitute this difference in the y column and this difference in the x column into this formula, I end up with a positive 4 divided by a positive 1. And that will equal a positive 4. And what I've done is I've found the coefficient of x by doing that. So I know that the coefficient in my equation that shows the relationship between x and y will be a positive 4. So that's how we figure out what the multiplier of the variable is. In this case, it's going to be 4. And now the second part to that is to find the constant. What is the plus minus value that goes in my equation? And to do that, all we have to do is take any ordered pair that we have in our table. In this case, I chose 1, 8. I could have chosen 2 and 12. I could have chose 3 and 16. It doesn't matter which one you choose. I'm going to choose the 1, 8. And what I'm going to do is I'm going to take my equation, and instead of saying 4 times x equals y, I'm going to take the x value of 1 and put it here. And I'm going to take the corresponding y value and put it here. So what I end up with is 4 times 1 is equal to 8. And when I simplify 4 times 1, I get 4 and 8. And since I know that 4 does not equal 8, what I've identified is I need to place a constant of plus 4 to balance the two sides. Because when I put a plus 4 constant in, this becomes true. And therefore, 4x plus 4 equals y is your equation. And as we've seen up here, we already knew that because I gave it to you before. That is the equation. And that's how you did it. So let's take another one. Let's just look at another one, another question. Let's just take, I'm going to give you a table this time. Okay? And I'm going to put a relationship between three, I'm going to put 1, 2, 3, and I'm going to put 5, 7, and 9. Okay? So if I was to plot these on a graph, so I'm going to go 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. And then I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'm going to put a 1 and a 5, which is 1, 2, 3, 4, 5, right there. That's 1, 5. And then I'm going to put a 2, 7, which is right there. That's 2, 7. And then I'm going to put a 3, 9, which is right there. And if I look at those 3 points on my graph, when I graph them, what I've created is this straight line. So what we can say is those 3 points, or those 3 ordered pairs, have a linear relationship. Because when plotted, they form a line. The linear, right? And that relationship can be quantified into an algebraic equation. So what we'll do here is we'll say, okay, remember what I said before. The relationship between x and y, there's an equation for it, okay? This equation may or may not have a coefficient and may or may not have a constant. But what we're going to do is we're going to look from the table of values to determine if it does. So the first thing we're going to do is see what is the coefficient, if there is any. And the coefficient of x is defined as being the difference in the y column divided by the difference in the x column. Okay? So the difference in the y column, if we go down here, the difference in the y column is adding 2 each time, so we're going to put that up here in my formula. And the difference in the x column is going to be adding 1 each time. So I'm going to put that here. And therefore, positive 2 divided by positive 1 is a positive 2. And that means that 2 is my coefficient of my equation. Okay, so I'm going to put that 2 right there as my coefficient. So now I'm looking for this relationship between all of the x values and y values in the table. And I've known that I'm going to be multiplying my x value by 2 and adding something or subtracting something from it to get the y value. So then I'm going to take any of the ordered pairs. I always like to start with the smallest pair, so 1 and 5 are the smallest. And I'm going to take my x, and I'm going to take my y, and I'm going to change it to x is going to become 1, and y is going to become 5. And I'm going to say, well, 2 times 1 is 2, and 5 is over here by itself. What constant is required? Obviously, in order to make the two sides equal, I need a plus 3 constant. And therefore, the constant in my equation is plus 3. And this, right here, is the equation that defines all of the points on this line. So I can write that equation, 2x plus 3 equals y, right on that line. And what that means is if I take the x value in any of these 3 ordered pairs here, this one, or this one, and if I multiply the x value by 2 and add 3 to it, I will get the corresponding y value. So once we have that, if we were to take any of these ordered pairs, so let's just take another ordered pair like this one here, 3, 9. So if I was to put a 3 in where the x is, and a 9 where the y is, I would know that 2 times 3 is 6, and 6 plus 3 equals 9, and I know that both sides are equal, and then 2 times the x value plus 3 does indeed equal the y value. And the nice thing about linear relations, it doesn't just work for the values that we know on the table, it also works for values that we could know if we extended the line. So for example, if I was to keep going down this here, and I was to ask you what would happen, where would the y value be on this line up here when x is 10? Now, although I could draw it and graph it and extend the line and connect the dots and figure out what the y value is, because I now have the equation and I know the linear relationship between the points, I could simply take my x value and substitute 10 into it. And when I simplify this using BEDMAS, I would realize that the corresponding y value, or where it would exist up here on the y-axis, when x is 10, right down here somewhere, way down there, the y value would be 23. Okay, so that's what we can do with linear relations. So essentially what you can do is, if you were given a table of x and y, or if you were given a graph with points, either way, you should be able to, let's pretend we'll go with 1, 2, and 3, and 10, and 15, and 20, and we'll make this 1, 2, 3, 4, then we'll go 10, sorry, we're not going to go 10, oopsie daisy, we got to move these dots up a little bit, we'll go 5, 10, 15, and 20, and we'll put our points in, 10, 15, and 20. And given that this is the table and this is the line that matches it, we should be able to find the algebraic equation that represents the relationship between x and y. We'll do that by finding the difference here, which is 5, and the difference here, which is 1. 5 divided by 1 is 5, and that's my coefficient. Substitute an ordered pair in. 5 does not equal 10, so I have to add 5. And therefore, this is the equation that matches this table and all of the points on that line. So every point that's on that line, if you take the x value and multiply it by 5 and add 5 more to it, you will get the corresponding y value.